Hello there! In my last video, I've talked about XSS and the two main strategies you can use to protect your applications against them: encoding and sanitizing. I've also described most of the impacts an XSS can have, and if it is not clear to you yet that XSS are one of the worst vulnerabilities in the web, go and have a look. It is worth it. In this video, I will go a little deeper and I will explain how you should encode and or sanitize. As we saw last time, most frameworks and template engines do encoding by default. You should never develop your own encoding functions, as it is really hard to think of all the edge cases and of all the characters that need encoding. I won't talk too much about encoding in this video, because you should always use a framework or a template engine that does this by default. This is going to help a lot, both for security and for developer experience. There's just one thing which is good to know about encoding, and it is about context. An untrusted value might be used in an HTML context, in JS, in CSS, or even in a URL. Encoding won't exactly be the same depending on the context on which a string is encoded. If your framework or your template engine requires it, such as Trig for example, you should be careful to specify the right context. Some frameworks use the correct escaping function, depending on the context on their own. Now, I'll talk more about sanitizing, which you should use when you bypass encoding mechanisms. For example, if you allow your users to add rich text content in your application. Sanitizing consists in stripping a string of all of its dangerous content. But what can be dangerous in such a string? In my experience, if you try sanitizing by yourself, you are likely to make some mistakes and forget some edge cases. For example, when I ask developers what are the different ways to add JavaScript in a page, they often only think of the script tag. But this is by no means the only one. There are actually 3 main ways JavaScript can be added and executed in an HTML page. First, in a script tag. The JavaScript is either within the HTML tag or in a file whose name is specified in the src attribute. Second, in a handler, such as onClick or onFocus. These are triggered when something specific happens, either an action of the user, for onClick or onMouseOver, or an automatic event, for onload or onError. Finally, in a link. JavaScript is a pseudo-protocol interpreted by browsers. If the src attributes of an A element start with JavaScript : instead of HTTP or HTTPS, the following code will be executed as soon as the user clicks on the link. As you can see, it's really easy to forget some edge cases or to make mistakes when designing your own sanitizing functions. That's why you should always use existing battle-tested libraries for such a critical job. DOM Purify, HTML Purifier are good examples of such libraries. Moreover, some frameworks and template engines do not check if links are safe. Imagine you authorize a user to specify their personal website in their profile page, for example. Angular will prevent the use of JavaScript : but React will not. So if you need a similar feature, you should always check that a link provided by the user starts with HTTP or HTTPS. The last point I would like to make is that as they are critical security libraries, sanitizations and encoding libraries are likely to be targeted. So, as for all dependencies of your project, you should monitor known vulnerabilities in these libraries and update them as soon as possible. At the time of writing this video, about 23% of DOM Purify downloads in the last 7 days were for a vulnerable version of the library. This data was obtained thanks to a tool created by Ren Paris, a JavaScript developer and secure code trainer. So do not be a part of these 25% and keep your libraries up to date. To summarize, to protect your application from XSS, there are 4 main steps. First, use a framework or a template engine that encodes by default. Second, if you need to bypass the encoding, always sanitize the output, and use a library for that. Don't reinvent the wheel. Third, be very careful if you have dynamic URLs whose content comes from user input. And finally, be sure to upgrade the libraries you use for encoding and sanitization. That's all for this time. In future videos, I will be more concrete about how to protect your applications against XSS, depending on the framework you use. And I will start talking about other vulnerabilities. Feel free to share these videos to all your fellow developers, and if there are subjects you'd like me to talk about, tell me in the comment section. I'm looking forward to reading your feedback. Bye!